Okay, yesterday we discussed functions. So yesterday we discussed functions. I told you f is a relation from A to B. Okay, f is a relation from A to B. So f is a relation from A to B. Okay, f is a relation from A to B is called function. Okay, if I told this condition, if for every element in A there exists a unique image in B, unique image B belongs to B. Okay, this is what is function. So that means here for every element, example I gave you is, let's take here B is there, A, B, C, D. Now if A is image of A is B, image of 2 is A, image of 3 is C, let's say. So now this is what is a function, because see, for every element in A, that is for 1, for 2, for 3, there exists unique image, okay, in B, unique image in B. For 1, only one image in B, for 2, only one image, for 3, only one image. This one we discussed. And also let's take another example. AB is there here. This is a function. So 1, 2, 3, 4. Let's take here A, B, C. I'm taking. So 1, there is image, 2 image, 3 image. This is function or not? This is not a function, because 4 doesn't have. For every element there should be image. No? For every element there should be only one image. So for 1 there is image A, for 2 there is only one image A, for 3 there is image B, for 4 no image. So it's not a function. So another example I'm giving, 1, 2, 3. Here A, B, C, D. So let's say now here 1, now like this I gave. So this is not a function. Why? Because for 1 there are 2 images. 1 there are 2 images, 1A, 1B. So therefore it's not a function. 2 there is one image, 3 only one image, 2 there is only one image. Therefore this is not a function. If I write like this here, then this becomes function. For 1 there is only one image. For 2 there is only one image, A. What is the image of 1? A. What is the image of 2? A. What is the image of 3? Only B. What is the image of 4? Only B. So like that, this became a function. This is not a function now. This became a function now. This is not a function because 1 has 2 images. Here 1 has one image, 2 has only one image, but 1 and 2 have the same image. That's okay. 1 and 2 can have the same image, 3 and 4 can have the same image, but here 4 elements have image and 1 has only one image, that is A. 2 has only one image. So here what happens is, see, for every element in A, that means every element should have image. So now already we discussed what is domain. We discussed domain means what? The set of elements in A which are connected. Na? So here whenever we say function, every element should have image, so every element comes under domain. Therefore domain is all elements in A. Okay, domain is all elements in A. So what is codomain? Already we discussed here. Function means what? How do we represent f maps A to B? When f is a function from A to B, f is a function from A to B, f is a function from A to B, f is a function from A to B. A is simply domain. A is simply domain. Okay, this is what is domain. This becomes what? Codomain. Codomain. Then what is range? What is range? Range is what is set of images. Set of images. Okay, this we can write like this. Set of images. What are the images in this case? A, B, C. These are images. This is range. Already you learned what is range for relations. So already we know that is. Just a minute. Okay, now let's take an example. So f is a function from R to R. This is infinite function I'm talking about. R to R defined by f of x equal to 2x minus 3. So like this I defined this function. So now here this is a function. I gave an example. This is a function defined by f of x equal to 2x minus 3. This is infinite function. You know why also infinite function like this. So whenever I say function, two things: where to where it is function and how it is defined. how it is defined. These two things are important. Whenever I say function, two things are important: where to where and how it is defined. So here, if at all you write the function, so this is infinite, so therefore you cannot write this arrow diagram won't be there. First of all, this arrow diagram won't be there. Here, if you take x, that means if you take some few elements, I am taking so many elements will be there in between 1, 0 and 1. So here -1, let's say after 0, so many elements will be there. So for 0, what is the image? -3. Few elements I am writing. Okay, for -1, what is the image? -5. For 1, what is the image? -1, like this. So few elements I wrote. So like that, it is infinite. So now this is definitely a function. Why? Here you can see for every element, for 1 only one image is there. What is the image? -1. Okay, for 0 only one image is -3. You will not have, see, if you put x value 1, you will get only one image. No, for 1 image -1, for 0 image -3, for 5 image is 7. Only one image you will get. For every element you get only one image, and for all the elements, whatever real number you put here, you will get an image. So this is, therefore this is called a function. So this function arrow diagram won't be there. This function is like this only. So you may ask, what is not function then? So for example, f maps R to R I defined. Okay, defined as f of x equal to plus or minus 2x. Let's say I defined like this. So this is not a function. Why it's not a function? Whenever I say plus or minus 2x, it's not a function. Why? So f of 1, for f of 1, here if at all, whenever you say function, first you should say function where to where, real numbers to real numbers, and how it is defined. That means image of each element is what? Image of each element x is 2x minus 3. That means you take from real numbers, you take whatever real number you take, you put here, you will get your image. For -1, what is the image for -1? So I told, no, for -1 image is -5. You put here -1. If you put here -1, x value here also 2 into -1, -3. So -5 you got. So image of -1 is like that. You will get all images. For every element, only one image you get. Okay, for you see here, for 1, how many images I am getting? Plus or minus 2. For 1, I am getting 2 images. For 1, I am getting 2 images. 1 minus 2 and 2. So therefore, this is not the function. Over. So whenever we have this plus or minus, so it's not a function. Like that. So this is one case. And another case I will tell you is f maps natural numbers to natural numbers, defined as f of x equal to, like that, 2x minus 3 only. Let's say 2x minus 3 only. So that means here, whatever natural number I take, I should get its image in B, in n to n only I said. So here n to n. So if I take in one natural number 1, I can take here. If I take natural number 1, so what is the image? -1. So where I should have its image? I should have its image in B. So -1 won't be there. In this -1 will be there? No. 1, 2, 3, 4 will be there. Natural numbers to natural numbers. Therefore, this is also not a function. Because every element should have image, but 1 has no image in B. 1, image of 1 is -1. That is not there in B. In B, it's not there. Therefore, this is also not a function. Like that, you have to check. This is about function. All right. So then next, types of functions. Types of functions. So types of functions. So what are the types of functions? So there, one is a one-one function. One-to-one function. Number one, one-to-one function. Number two, on-to function. This only can be, or this can be called injection or injective function. Injective function, or this only simply you can call injection. Injective function or injection. So what is that? Definition is simple. F is a function from A to B, right? F maps A to B is called, first it should be a function. This function is called injection. Injection, if it satisfies the condition. What is that? If different elements of A, different elements of A have different images. different images. Different elements have different images. That means, or you can say, or no two elements, the same meaning. No two elements have same image. Different elements have different images means no two elements have same image. So now, for example, so first we'll take finite function. So now this we take a, this is b, this is a function from a to b, 1 2 3 x y z. So here I think you can understand this is a function. This is a function. This is a function. 1 has only one image, 2 has only one image, 3 has only one image. So every element has image, and every element has only one and only one image. So therefore it's a function, everybody knows. So here if you see here, this is one function or not, you check for yourself. One function or not, you check for yourself. One function or not, you check for yourself. First one function or not. Second, one function or not. Third one, you can check for yourself, one function or not. So first one, different elements have different images. 1 2 3, three different elements have different images. No two element has same image, therefore it is a one function. Now second one is one function or not. Second one is one function or not. One has, first of all you have to check whether it's function or not. So one has only one image, two has two images, therefore it's not function. First of all, it's not function. So one function, not one obviously, one function, because first it has to be, f is a function. Function is said to be injection if it satisfies this condition. Different elements have different images. Now third one, if you see, four different elements are there, means here four elements must be there. Four elements must be there. Different elements should have different images. That means four different elements should have four different images. So here 1 and 4 have same image. 1 and 4 have same image. So f of 1 equal to f of 4 equal to b. F of 1 also image. So that means what? Different. See, different element here, two different or distinct elements have same image. So not one function. Why? Two different elements, 1 and 4 have same image. So therefore it's not one function. Like that we can give another example also. A, this is b. So here 1 2 3, here A B C D. So here this let's take like this. So this is one function or not? First of all, it's function or not? Yes, it's function. How do you know it's function? See, here 1 has only one image, 2 has only one image, 3 has only one image. So you have to see different elements, 1 2 3, different elements have different images, therefore it is one function. Why? Because three different elements have three different images. Okay, then what about C? Doesn't matter. Here three different elements have three different images, therefore one function. So this is how we write one function. All right, so then, yeah, next. Now this is an example for finite functions which are one. Finite functions which are one. So now let's take the next example. Let's take next example. F maps R to R. Defined by f of x equal to 2x minus 3, like before only I'm taking. Whether this is one function or not? Yes, one function. It is one function. One function. Why it is one function? Because different elements will have definitely different images. Different elements will definitely have different images. How do we know? Because if you substitute 1, you get -1. If you substitute 2, if you get some 1. So different elements if you take, you will get different images. No two elements have same image. So no two elements have same image. See, here two elements have same image. Like this, if you take different elements, you will get, say, different images only. So how do you prove? How do you prove? There is a way to prove it. What is that? Let's take two different elements. Let x1 comma x2, we have to take from A. Set A is what? Two real numbers you take. How do you take? Such that x1 is not equal to x2. two different elements. See, I have taken two different elements. Then if you multiply also, they will not be equal. If you multiply same quantity, they will not be equal. If you subtract same quantity, they will not be equal. 2x minus 2x2 minus 3. So different elements if I take, image is also different I get. See, f of x1 also not equal to f of x2. That means here in the place of x1, x2, you take any two real numbers. You can prove like this. Different elements have different images. Therefore, what you can say? F is 1, 1. Like this you have to prove. If at all you have to prove. Because here x1, x2, which real numbers? You don't know. Therefore, for every real number, generalization it's called. For any two real numbers, you take any two different real numbers, x1 not equal to x2. For any two different real numbers, you will get different images like this process. That means x1, x2, you take whatever you want. So x1 equal to, I am taking minus 1, x2 equal to, you take 3. So minus 1 is not equal to 3. Obviously, if you multiply minus 2 not equal to 6, minus 2 minus 3 not equal to 6 minus 3. Obviously, therefore, f of this is f of minus 1 not equal to f of 3. Like that, some different elements if you take, image is also different. What are the images? This is image minus 5, this image is 3. So like that. So this is 1 1, not this is 1 1 function. Different elements have different images, therefore it's not 1 1 function. Now you may ask, what is not 1 1 function? So what is not 1 1 function? So let's take example 2. So f maps R to R defined by f of x equal to x square. This is not 1 1 function. How do you know? How do you know it's not 1 1 function? Because f of 1 equal to 1, f of minus 1 is also 1. So that means different elements have same image. See here, this is 1, minus 1, this is 1. So here if you take 1, this is for minus 1 also, 1 also, same image. Different elements have same image, therefore it's not 1 1 function. So not only that, f of minus 2 is what? 4. F of plus 2 is what? 4, like that. So two different elements have same image 4, therefore it's not 1 1 function. So how do you prove? Proof. How do you prove? Now let's take two different elements. What is that? x1 comma x2 belongs to R, domain. R is what here? Domain. If you take domain, how do you take? Such that x1 is not equal to x2. If you take, when x1 is not equal to, you cannot say this is wrong. x1 square is not equal to x2 square. This is not possible. Not possible. You cannot say this. Why? Because minus 1 already I gave here. Example. Why not possible? Because minus 1 not equal to 1, but minus 1 whole square, its image is minus 1 whole square, but equal to 1. This will not get, not equal to is not possible all the time. It's not possible all the time. Therefore, what we can say, it is not 1 1 function. See, simply it is, you have to take like this example. Different elements have same image. Two different elements have same image. Different elements should have different image, but they have same image. Therefore, it's not 1 1 function. So now, how do you make it 1 1 function in this case? Now, if I write another example I am giving. So what is that? Example 3. F maps R plus real positive real numbers to real numbers defined as f of x equal to 2x minus 3. So then whether it is 1 1 function or not, whether it is 1 1 function or not, whether it is 1 1 function or not. So whether it is 1 1 function or not. So now everybody I think understand. F maps R plus 2R defined as f of x equal to x square minus 3, or even if you define f of x equal to x square, both are 1 1 functions, because here negative numbers are not there. All the positive numbers if you take, all positive numbers if you take, different elements will have different images. Therefore, it is 1 1 function. All right. So yeah. So, but if at all, yeah, if somebody is saying, if at all, f maps here R plus 2, if I take R plus to R plus, defined as f of x equal to x minus 3. Now it's not a function, first of all.
Not a function.
Not a function. Yes, it's not a function. Because here from R plus R2, you cannot write this. When you define f of x equal to x minus 3, you cannot write like this, because f maps and f is function from R plus to R plus. I cannot write this. It's wrong. It's not a function. Okay, if you take this one r plus to r plus to r plus, but if I define like this, not like this, but if I define f of x equal to x square, yes, then this is a function, also one function. This is one function. This is, yes. So hope you understand this one. But how do you prove this? I'm going to tell you one proof for this. You can also prove like this. What is that? Yeah, example. How do you prove this one function? How do you prove this one? Actually, how to prove like this? Let x1 comma x2 belongs to R plus domain. You have to take in the domain such that images are equal. Even images are equal. If images are equal, then what will happen? X1 square equal to x2 square. That implies what? X1 equal to x2 you will get. Therefore, it is one function. One function. What does it mean? If I put not equal, this will be not equal, this will be not equal. So instead of doing that, you can take images are equal. If images are equal, then this functions also becomes equal. Now you can take this one. Notes, I don't know.